Good afternoon, everyone. Welcome to the April meeting for the North Texas AMS chapter. So first, I hope everyone enjoyed the eclipse. I know the cloud forecast looked a little bleak there in the prior days up to it, and but the seas parted, and I think most everyone here got a pretty good show. So hopefully y'all enjoyed it, whether you're here in North Texas or if you traveled elsewhere across the country for it. Just great pictures, great videos, just a great experience for all. So let's go ahead and jump right into our speaker. Our speaker is going to be Doug Speheger. He has been a meteorologist with the National Weather Service Forecast Office in Norman, Oklahoma for the past 30 years, and he's currently the lead meteorologist there. A lot of his work is involved with the research and forecasting of Southern Great Plains weather, including severe events, severe thunderstorms, tornadoes, and fire weather in particular. He has presented at several conferences and has authored and co-authored a few manuscripts and papers. He did his undergrad at Purdue University, who almost pulled it off yesterday. It's so close. And then finished his master's here at the University of Oklahoma. So with that, Doug, the floor is yours, sir.
Okay, well, thank you, Steve. Yeah, that would have been a nice touch to end the day with a Purdue championship last night. But between total eclipse yesterday, having some, my daughter was at a dance competition this weekend and did wonderful. So it was still a great weekend. So let's see. Can you see my screen? Okay.
Yes, sir.
Okay. So as Steve said, I came to Norman in OU and Norman initially, with a focus of severe weather and tornadoes, as a lot of people, do, since that is a big thing here in Oklahoma and Texas. But over the last, after the last few years, we've seen a lot of events, with wildfires, here as well. And so started working with our science officer here, Todd Lindley, who's helping to make some, kind of advances in wildfire, forecasting and even warning, to kind of get people, to react and get out of the way should a fire come. I mean, a big wildfire it can be, just as bad as a large EF5 tornado, because, when the fire's moving through, there's nothing left with your house, many times. So these can, create damage on scales that we, even greater than we see with tornadoes. So we've been kind of taking a look at that here over the last few years. And of course, a lot of people, when they think of wildfires, think of more, California, the West Coast, and, just kind of mountains out west. But where have the largest wildfires occurred? If we kind of take a look at the top 10, well, actually, I'll put 11 on there. Largest wildfires in the contiguous United States since 2006. We got some out west, like we expect. Number 10 was the Martin Fire out in Nevada, Holloway Fire back in 2012 in Nevada into southeastern Oregon. Number 8, okay, this isn't out west. This is the border fire from what was part of the East Amarillo complex fires in March of 2006. Comes in as the 8th largest, wildfire in the contiguous U.S. here since 2006. And I went ahead and threw in the other significant fire from that complex, the I-40 fire, which would have come in right at number 11. So there's our bonus 11th, largest fire that we've experienced. The Wallow Fire in eastern Arizona back in May of 2011 near Alpine, Arizona. back up to the West Oregon with a long draw fire, number 6 in July 2012. Murphy Complex in Nevada and Idaho in July 2007. Then what? Okay, we got another one here in the Southern Plains in Oklahoma. Started in the Oklahoma Panhandle, moved into Kansas. The Starbuck fire. Excuse me a second. Excuse me. Sorry about that. Didn't have time to find the mute button in time either. But the Starbuck fire in May 2017 started in the Oklahoma Panhandle and spread north into Kansas. Then we get back to our California fires, the Dixie Fire in July of 2021, just a few years ago. The August complex of fires in August 2020 out in California. And then we have a new number 1 as of a month and a half ago, the Smokehouse Creek fire that affected the Texas Panhandle here late in February, just a month and a half ago. Just even on a national perspective, you can see how large that fire was. It's only, it and the August complex in California are the only fires in the last 18 years that have gotten 1 million acres of that were affected in the perimeter of the fires. So that's a pretty big deal, and you can even see the scale of it here on this almost national map. But if you look at it real close, it's like the fire stretched for 94 miles. From it actually started at the kind of northwesternmost point there near the town of Stinnett. And then we had a secondary fire that formed just south where the 94-mile line is, and then merged into the large fire. And initially, it runs 94 miles through the Canadian River Valley from near Stinnett, Texas, into far northwest Oklahoma, northwest of Gage and Arnett. And then what often happens with wildfires in the plains is you get a kind of initial push of the fire, and in this case it was behind a tri line, so we had lots of westerly winds, and it pushed from Stinnett all the way across most of Hutchinson, all of Roberts, all of Hemphill County into Ellis County, Oklahoma. And then we get a wind shift, and that causes complications too. And now as the cold front comes through, now we've got northerly winds, and now wherever there's still fire along the fire line is now a multi dozen mile long head fire that's now moving south. And so that gave it the south push across Roberts and Hemphill County, especially. And you can see that looking at the fire to the south in Gray County, is it's much smaller. It made the run from west to east, but with firefighting efforts and a little bit better terrain to deal with, it wasn't in the Canadian River Valley breaks. They were able to get that under control. So when the cold front hit it, you don't see that big surge south with that fire. To give you kind of another perspective on how large that fire is, if we were to displace that over the Metroplex, the fire would have started near Weatherford, Texas, over in central Parker County, gone all the way across Tarrant, Dallas County, through all of Rockwall County. Initially, like I said, it would have spread west or west to east across the northern part of this perimeter, and then when the wind shift hit it, spread south. But that's what the fire perimeter looks like if it were to be overlaid on the Metroplex, to just give you kind of a perspective on how huge this fire was. So if we take a look at the map of what are called mega fires, or fires that are over 100,000 acres since 2006, you see a lot of them in the west, but you see an awful lot, here in the Southern Plains too, Kansas, Oklahoma, Texas, um, and you know, part of what makes them so big here is we're dealing with kind of a different scale of fire in a lot of cases. Uh, the fires in the terrain in the mountains in the west in the forests will usually be very prolonged fires that will most of the time, not always, but spread kind of slowly from day to day unless there's a windstorm, like some of the significant fires that we've seen out in California. You'll get a day or two where they get significant spread because of you know the Santa Ana winds or other strong wind events. But in the Southern Plains, we're just on a different scale. We're not in heavy timber with the fires, we're in grassland. And so and we're definitely not immune to the wind here. In fact, wind is pretty common here in the spring in Oklahoma and Texas. So with short fuels, usually not quite as much to terrain to deal with. The fires in Texas and Oklahoma can spread very rapidly, and there'll be cases where we've got an 100,000 acre fire, just 18 to 24 hours after the fire has even started, with some of the more significant fires. So hopefully they're not as prolonged as some of the uh, as far as number of days that the fire is active in as some of them in the west, but the ones here in the plains can move very quickly, very fast. Kind of looking a little bit closer at Texas and Oklahoma, and even you can probably include that one in southeast New Mexico that's more in the plains than in the mountains of New Mexico. You can see there's just quite a few that have affected Texas and Oklahoma since 2006. We have 17 megafires that have been occurred over Kansas, Oklahoma, Texas, the Southern Great Plains here in the last 18 or so years, and 13 of them have affected Texas, including just the Smokehouse Creek fire that we had just a month and a half ago across the Texas Panhandle. So with all these, our science officer Todd Lindley had times where he was stationed at some of the West Texas offices, Lubbock, Amarillo, and so with them having to deal with wildfires occasionally like that, he started really looking into what we could do to improve National Weather Service services for events like this. I mean, you know, wildfires aren't really directly a weather phenomenon, but weather plays a significant role in the development and spread of fires when the humidity and wind is in the right conditions. And we have some tools that can really help with that. So we started really looking into this, a lot more significantly here over the past, 10, 15 years or so. We found typical weather patterns that will be conducive to the wind and the humidity that we get to create an environment that these fires, should there be a spark, can spread quickly. We usually see a low-level thermal ridge right nearby, give us some of that heat associated with the dry, low humidity conditions. We see little jet streaks coming out in the upper patterns, which can influence, especially if you mix very well, get the wind to the surface. So we've been doing a lot of work in the weather patterns that are conducive to those wildfires, and are being a lot more proactive in when we see those coordinating with the state agencies, Oklahoma Forestry Service, the Texas A&M Forest Service, and local fire weather agencies that, we may have a bad fire day coming up. They've been doing some modeling work with the Texas Tech WARF model, working with them to help get, some of the information that we like to see, actually modeled and plotted. So this is something, this map is something called the Red Flag Threat Index, where, the yellows are kind of low on the scale, and then the reds and the dark reds are where it sees humidity and wind patterns that are climatologically abnormal for, even us in the plains, that can tell us, okay, this is, very low humidity, very high wind. This is an area that we're going to have to watch for. And then just on the coordination side, we have done a lot of work with Texas A&M Forest Service, Oklahoma Forestry Service, to, kind of put together a working group where we can pass information on to them for what we see in the weather, but we still have an incomplete picture too. They have the expertise on what the fuels are doing, how dry the grasses are, how conducive are the grasses to spread of wildfire. If we've been in a prolonged drought, and and sometimes it doesn't necessarily have to be that long of a dry period, where the grasses, especially since they hold very little moisture, dry out very quickly. But it's those state agencies and the local agencies that are more familiar with how those are going. So that's an important part of the fire weather picture too. So we developed a working group with many weather service offices in Texas, and even Kansas and Oklahoma, as well as state forestry officials in Texas, Oklahoma, and Kansas, where we've got a working group where we're sharing this information during fire season all the time. We're telling them about concerns that we see in the weather patterns. They're telling us about concerns that they have or don't have with how the fuels are doing. And then we just coordinate very closely when both the weather conditions and fuels are bad. And we'll kind of talk about that here in a second. But another thing that we've been kind of doing unofficially, for 20 years, is satellite has shown very useful in being able to detect heat signatures associated with wildfires. And we've seen that even from the previous generation of satellites. And during fire weather days, we would take satellite images, kind of point out where it looked like wildfires were occurring, and put that as a graphic on our website to help local agencies and the state agencies kind of have a big picture idea of where fires are burning. Back about it's probably been 7-8 years ago, we started taking that to the next step. We well, first of all, let me kind of show you what we're seeing on the satellite here. On the far left corner, you can see a black spot with areas of red in the infrared satellite image, and we've kind of developed a color table that once the temperature, the brightness temperature that we see on infrared hits certain points, then we've changed the color scale to go from yellow to orange, red, and then even black. So on the far left satellite image, you can see a heat signature that's developed that we can see in the infrared satellite across northwest Oklahoma to the west of Alva. And then just even a few hours later, this was one that was a little bit slow to initially spread, but then when it started spreading, it became very efficient. But we had generally south winds, so from our initial wildfire that developed up in northwest Woods County, Oklahoma, you started seeing the fire spread and the fire, kind of, the blowing embers spark downwind fires. So you start getting, the wildfires spreading into southwest Kansas. And then when the dry line moved through, you can see how the heat signatures, kind of spread off that north-south line of fire and just really started to move to the northeast. And you can see how large the heat signatures got, because now you have like a 40 or 50 mile flame front that now the wind has shifted, and that entire 40 or 50 mile flame front is now a head fire moving northeast. So, like I said, years ago, we'd started kind of making graphics about that, but then we took it a new level a few years ago, where we developed a system here where we can monitor. We actually, if it's going to be a fire weather day, we assign a staff member specifically to be on fire watch, kind of similar to what we would do to have someone specifically assigned as a radar operator during a severe weather day. And so this is me at that role on one of these fire days, just continuing to monitor the satellite. And if we see a wildfire develop, and the new GOES satellites have been in place for 5 or 6 years now, however long, has really improved both the spatial resolution that we can see, but also temporal resolution, where if we have a day we're concerned about quick developing and quickly spreading wildfires, we can request that the satellite folks put what's called a mesoscale sector over our area, in which case it's just a subset of the United States, but we get rapid fire satellite information, one picture every minute. So, usually if we're not in a mesosector, we'll see an image updated every 5 minutes, but, getting the extra temporal resolution of getting satellite every 1 minute, we can see these fires develop very quickly. So, we developed a system here where just even on our computer workstations here at the Weather Service, if we see something develop, we can put a point marker on the location where that hotspot has developed, push a couple of buttons, and it will generate a text message that can automatically be sent to state forestry, a state emergency management agency, and there's some local departments on this as well, although primarily, at least here in Oklahoma, we generally have the state forestry then kind of coordinate with local agencies to determine. It's like to tell them that we see a heat signature here, see what they know, and if they don't know about it, get a response team to act quickly. And that's actually done very well in getting the fire crews ahead of it. This hotspot notification was developed about 8 years ago here at our office in 2016, and through the use of this over the years, 70 to 80% of National Weather Service hotspot notifications, even if it's going through the state and through the state to the local department, the local department actually gets notification through that system before any 911 calls about that fire are called in from the public, 70 to 80% of the time. So, that is invaluable in that if we can get them quick notification of a wildfire, and they can get an initial attack on that fire before the winds really start spreading it, to be very large, that can make a huge difference in what we end up with. So, that's one big thing that we've been working on, and very proud of what we've been able to accomplish. And so, we've been going with that for, for a number of years. And then it wasn't in our it wasn't in the Southern Plains, it wasn't in our forecast area, but November 8th, 2018 turned out to be a big day where we decided, what else can we do? And that was the day of the so-called Camp Fire in California that swept through the town of Paradise. And I'm sure you all remember the news stories about that, where it swept in so quickly that, yeah, and being in the mountains, there are only limited options to get out of the way, which of course didn't help the situation either. But we ended up with the fire just going through Paradise, Concal, and some other areas, some other towns and communities in the mountains there, just east of Chico, California, and just absolutely destroyed those towns. And even though we've not had an event exactly like that, even that day and that week, our management team at our office is, okay, can we do something to improve the warnings? We've done this work to improve firefighter response and firefighter preparedness, but what can we do to take that next level to help warn the public? And so this turned out to be the start of a multi-year kind of coordination with Texas A&M Forest Service, Oklahoma Forestry Service, and the equivalent in Kansas. That we already had a working group established where we're doing these things we'd already talked about as far as coordinating on fire weather, events leading up to the event. But we start talking, okay, what can we do now? So over the last few years, we've developed a system where we can create coordinated fire warnings, where we work with the state agencies and in some cases local agencies to try to get out that much more ahead of getting warning to the public if there's a threat that they could be threatened by a wildfire. So, as we've done for years before, step one is coordinate on weather and fuels before any wildfire starts. Are conditions conducive to rapid fire growth and rapid fire spread? So we've kind of developed a matrix where we look at both the fuels, the information that we get from Forestry Service, and the weather conditions. And so, like with the fuels, we kind of look at it as percentile of how dry the fuels are relative to normal for that particular area. So, if you're below the 25th percentile of dryness, that means your fuels are pretty wet. If a wildfire breaks out, we've always had the ability to, if a local emergency management agency or fire department wants us to issue a fire warning for a wildfire that threatens a community, we will gladly do that, get the information out through weather radio, through the media, through the channels that we already have going. So if we're below the 50th percentile of dryness, meaning the fuels are pretty wet, not as conducive to spread, we'll still do those local requested fire warnings. But it's when we get to the very dry conditions that we can take another step, as kind of indicated by the yellow and red areas. And then also at the weather conditions, we look at, if the weather conditions are not really conducive to fire spread, we've got low winds and high humidity. If a fire breaks out and we get a request, we will gladly issue that fire warning. But it's this kind of upper right corner in the yellow and red where, if fuels are dry and we've got weather conditions that will, be conducive to rapid spread, we start taking it to another level. And we've got some thresholds listed there that, if we're in the yellow, if we see a brightness temperature on a satellite of around 95 degrees C. We will, uh, we will, and it's going into kind of a more populated area, what's called the wildland urban interface. Then we will start, you know, start coordinating with the state forestry. Is this fire a threat? Do we need to get a fire warning out and be proactive with it? If it's a wildland intermix, a more rural area, the temperature threshold's a little bit higher. But then, you know, if we're into a situation where the weather conditions are extreme or historic as far as wind and low humidity, and the fire and the fuels are 70th percentile or drier, then we actually lower the threshold more because we know how rapidly fire can spread in those conditions. So if we see a fire in a rural area that has a brightness temperature on satellite of 70 degrees C, we start this process. If we see it's going toward a town or a population center, or there's some value at risk at the wildland urban interface, you know, we lower that threshold even more. If we see conditions, if we see brightness temperatures at 55 degrees, you know, centigrade, we'll start this process. So, you know, here's one that developed just north of Oklahoma City a couple of years. This was actually last year, March of 2023. On the lower part, you know, I've zoomed in. This is the north side of the Oklahoma City Metroplex. You have one fire that started in Oklahoma City Metroplex or the Oklahoma City actual area, North Oklahoma City and into Edmond. And then this one, the fire just to the north that we can see on the time lapse, developed between Edmond and Guthrie, just north of Oklahoma City. And the blue line is Interstate 35. So initially this fire developed west of Interstate 35, but it's moving towards the interstate and there is some population there. So we got a notification out to the state agency. We use the same system we use for the wildfire notifications, but we have special wording in there that's like, okay, we see a potentially dangerous wildfire now that has met our temperature thresholds, and this is some key words that the state forestry agency looks for to know that we're concerned about this and we're wanting to be proactive. Do we need a fire warning for this? So that's finding candidate fire identification. And then the next step is state forestry will kind of use their tools. They're in touch with the instant commander, if they've taken over the fire or if it's still a local jurisdiction fire, but they have the contacts to coordinate with the instant commander, find out about any threats to people or structures with that fire. And then they can also do some fire modeling as well. So here's that fire, and the hot spot that we pointed out is that the red dot there, the blue dot kind of at the edge of where that green and red area is where the source was. So considering we're looking from satellite at so many miles above space, and the pixels are three quarter kilometer resolution or whatever it is, it's like often we're able to identify the fire despite those limitations to within a few hundred yards. So that's pretty impressive. It still kind of surprises me. But then they can run fire modeling and say, okay, with these fuels, with these humidity and wind conditions, what kind of spread are we going to get? And they see in this that, yes, this is going to move to some areas where there's population along Sooner Road. This is moving toward Interstate 35. So yes, we do want a fire warning. So as soon as they tell us that, we've got it in our system almost ready to go. We can get a fire warning out. Again, this is not something that we will do on our own. It's in coordination And so it's, we'll have the tag on there at the top of the fire warning. It's requested by the Oklahoma Forestry Service. Issue a fire warning for southern Logan County. Dangerous wildfire located 6 miles north of Edmond, moving rapidly east at 3 to 5 miles per hour. This will affect Interstate 35 between Edmond and Guthrie, and give warnings. Give that kind of first information to local citizens that be prepared to evacuate quickly, and so that within minutes or however long it takes, the incident commander, the state agencies, the local agencies can determine what areas they need to evacuate. But hopefully they already have a warning that evacuations may be coming. Be prepared now. So I think that has really helped us out on the public warning side things. If we go back to just a month and a half ago, the Smokehouse Creek fire, we've been doing this system here for a few years, and are getting other Texas Weather Service offices on board. And Amarillo, the office in Amarillo, decided to spin up their program to do this as well, and just this spring. But fortunately, it was before the Smokehouse Creek and the other fires associated that day that caused so much damage in the Texas Panhandle. So even though they had just kind of implemented this system, and it's probably less than a month or two since they said, okay, we're going to do this, this was a success. We, through coordination with the Texas A&M Fire Service and through, local agencies in some cases, this is a map of all the fire warnings that were issued that day by the Amarillo office and by our office. And we were able to get fire warnings out ahead of the fire spread in a lot of cases that hopefully helped preparedness and hopefully gave citizens, kind of an initial warning that this may be affecting you soon. Be prepared to evacuate if necessary. So we did some calculating, and fortunately, the Texas Panhandle, and especially the Canadian River Breaks, is fairly, sparsely populated area. Although it did affect some, towns near Miami and Pampa or Stinnett, and some of the it did affect some communities. But we looked at the 2020 census data, took the wildfire perimeter, and determined 3,700 people lived within the fire perimeter of Smokehouse Creek, and that's not even including the smaller the other fires that day. There were 2 fatalities, which of course we don't like any fatalities, but only 2 out of 3,756 people. So that was a fatality rate of 0.05%. Again, we don't like any fatalities, but if we kind of compare it to some other recent notable, rapidly spreading United States fires, like Lahaina, or the one on Maui, Hawaii, Lahaina, or some of the California rapid fires here lately, this is almost an order of magnitude less fatality rates than we've seen for others, some notably rapidly spreading United States fires. So we think and we hope that this has some utility. So kind of looking forward, what are going to be doing next? We've kind of shown the utility of this, and we've gotten some scientific publications out of this, like Steve mentioned earlier. And, initially, although some, management within Weather Service was initially, okay, we'll wait and see. We've shown the utility of it over the last few years. So the Weather Service headquarters is seeing the utility in this, and I think is coming on board with this. But there's still some questions. Will this method work elsewhere in the United States? Like I said, our fires are mainly grassland range fires that have a different time and space scale than some of the fires out in the Western United States. So we started looking at some of those. And our initial research suggests yes, it can. We looked at a few. We've got a paper that will be coming out very soon in the from the National Weather Association, where we looked at this methodology with the Camp Fire in California that affected Paradise, with the Marshall Fire near Boulder, Colorado, that did so much damage in Louisville and Superior, Colorado, and then another fire, the Kincaid Fire out in California as well. And our initial research suggests, yes, this can be productive elsewhere. We've seen, at least in an overview sense, if you take a similar methodology, it can work. But there's still some questions remaining with that because, so this summer, there'll be a fire weather test bed where we're getting more offices, both Weather Service and Forestry, involved in this test bed to see what this might be able to do in other parts of the country. One big question is, do satellite temperature thresholds that we use, do they need to be different in the West, given that theirs is often timberland fires as opposed to grassland range fires? The thresholds that we used when we looked at these other three fires, it's like it seems to do a pretty good job, but they may find better better thresholds for them to use out there. And of course, what our efforts have taken a multi-year coordination with state forestry fire agencies to kind of develop that. And so this process, even though we think we've shown the utility of it, and hopefully a fire weather test bed will show utility of it, there still needs to be that development work, at the local level or the state level, elsewhere in the country to get it to work. So that's kind of where we're going with that. Like to thank some people who have been very involved with this over the last couple of years, and then especially with Smokehouse Creek Fire, our science officer, Todd Lindley, and our meteorologist in charge, Mark Fox, here at the Weather Service Norman, Drew Daly and Mark Goler from the Oklahoma Forestry Service, Brad Smith and Luke Kanklertz of Texas A&M Forest Service. And then Amarillo, the Weather Service Amarillo really did a great job with Smokehouse Creek. And thanks to Mike Gittinger and Aaron Ward, the meteorologist in charge and the science officer at Weather Service Amarillo, to get that going in kind of just in time for force this that wildfire outbreak that included Smokehouse Creek and some others there. So that's that. I'll turn it back over to you, Steve.
Doug, thank you so much. That was great, and it was nice and timely to have that, since that was only a month and a half after that event. Plus, we're still in plenty of drought over West Texas and in New Mexico.
Right. Fortunately, we're greening up in most of Oklahoma and North Texas, the Metroplex, but we still got a little ways to go before we get good green up out in West Texas. So.
Yeah, it's just nice to actually see rain west of 35. So we'll take the little progress where we can. So we'll go ahead and open up the floor to questions here. We'll wait to see if someone online chimes in. I can start off with one here.
Okay.
So IMETs, incident meteorologists, they're typically deployed for events out west. Is that something that's done in the Southern Plains in Texas, or is these events too short fused to?
For the large wildfires, even though we may not be on the scale of months, like they sometimes have to worry about in the West. for the large wildfires, they will have an incident or an IMET, an incident meteorologist report. There was one assigned to Smokehouse Creek that basically showed up, the next day to help, because even though it's a shorter time scale in a lot of cases, especially a wildfire like Smokehouse Creek, where you have so much of the fire in the Canadian River breaks that's inaccessible to units, to fire units on the ground, where it's still going to take time, even though they might get it contained, it's still going to take time to get the fire out. So, IMETs will show up. We had a large 300,000 acre fire in western Oklahoma, north of Clinton a few years ago, called the Ray Fire. And we had an IMET from the Jackson, Kentucky Weather Service office come up and show up to help support that fire as they continue suppression activities for the next week or so. And then when an incident meteorologist shows up, we coordinated quite often with both the incident meteorologist and the fire weather behavior specialist who showed up for that fire. So the local office still works quite well with that. And the Ray Fire was actually another example where you had an initial development, kind of early afternoon one day, huge fire spread that afternoon and evening, and it was a mega fire of over 100,000 acres before midnight. But the next days weren't as rapid with fire spread, but we still had fire spread, and they had an instant meteorologist who showed up, but we still used our hotspot notifications in that case too, where if we see a flare up of a hotter heat signature develop near the perimeter of the fire, we let them know about that in case one part of the fire is getting a little bit more out of hand again. They can set units there to respond directly to it. So we spent the next 2 or 3 days even doing hotspots notifications of an active large fire to help with situational awareness for the instant commander and the crews on the ground that we've got a pretty significant flare up at this part of the fire, because they're spread out over so many miles with those.
Yeah, I can imagine it's a lot to try and cover such a large area. Are there any
Hey,
questions?
Doug. Oh, can you guys hear me? Our camera doesn't work, but
Yeah, we can hear you.
yeah, I had a question. I was out in the Texas Panhandle around the Canadian River, and it was very lush last year, right around the end of May, but getting a lot of rain, and I'm sure that's a lot of what burned. So I'm curious, when it's grassed, how quickly does that tend to restore itself to the point that your fuel base is kind of a risk again? Is it like in a year, or how long does that take given it's grass?
If it's an environment that is windy and has low humidity, which it can be actually on the matter of days.
Really?
Where the grasses are known as kind of short timeline fuels, where I don't know the specifics because it's more on the forestry side, but we got fuel levels from 1 hour fuels to 10-hour, 100-hour fuels, 1,000-hour fuels, which kind of gives a time scale of how quickly you can see changes in the dryness of those types of plants or grasses. And so the grasses are excuse me, are the fine fuels, the 1 hour fuels. So you can get significant changes and a lot of what we've seen in some of the bigger fires here in the Southern Plains has been situations like that, where we have like a warm, well, I guess it's more of a wet, a wet season where you showed in the Canadian River breaks where it gets a lot of grasses to grow. They can dry out very quickly in a matter of days, and then especially, you know, weeks or months if it's dry conditions. And now you have a lot of fuels that are just ready to burn. And some of our biggest fires have been in situations like that where um, the Ray fire happened after we had a very wet winter, or actually late fall when it was still kind of growing season and still had grasses growing. Then we get into winter, the grasses go dormant, they dry out, and you have all this grass that had developed in the late fall. It's dry and ready to burn, and that kind of fuel loading is very dangerous. But it can be on the even on Smokehouse Creek. There had been a little bit of snow just a few days or a week before, if I remember right. I mean, it wasn't a lot, but those grasses dried out very quickly within the matter of days, since we then went into a kind of windy and dry period that allowed the moisture to dry out in those fuels very quickly.
Yeah, very fast.
Other questions? I guess I'll ask one more here to close it out here.
Okay.
So, the Smokehouse Creek fire was obviously known for, having the fire front line go one direction and then shift because of a passing frontal boundary. I'm assuming this is going to be a softball question. I kind of know the answer to this, but are these big boundary wind shifts either from a front or a dry line kind of a predominant feature in creating these Southern Plains mega fires?
Yeah, especially the very large mega fires that get over 100,000 acres. That is a lot of what the problem is. That with the Anderson Creek fire, where I showed the satellite images, it made a 50-mile run, in the south winds from northwest Oklahoma into southwest Kansas. The front, the dry line moves through, and now you've got all along that 50-mile flame front, you've got advancing fire now. So that burns the area very quickly and very efficiently. Yeah, and in Smokehouse Creek, part of the problem was it was in the Canadian River breaks and pretty difficult to access to get any kind of initial containment on it. And then the winds and the humidity are very problematic for that one as well. So that one would have been a mega fire. That would have been well over 100,000 watts even without the wind shift. But then you get the wind shift. You have the fire now running for Miami and Perryton, or not Perryton, but some of those Northwest Texas Panhandle towns there. Excuse me. And that starts adding the area very quickly when you've got such a long fire front that's now a head fire that's long.
Yeah, it makes it challenging. Plus, probably don't have the kind of assets that they do out west with some of the planes and helicopters to do that.
Right, and this is another thing where the coordination with state agencies have really helped the situation. We've seen that here in Oklahoma the last 3-4 years, and seeing that in Texas some as well, where in our coordination with state forestry, even going days before a wildfire event, they have started to pre-position assets. They've started moving task forces. They've started moving helicopters. They've started moving, just a lot of resources that they have at the state level to be, it's like closer to where the action is. So, like, if we're concerned about, you know, 2 days from now, Northwest Oklahoma looks like it's going to be in pretty bad shape. They'll move assets, task force tankers, helicopters to Woodward, so that they'll be kind of pre-staged there and ready to go. And the response time, even for those kind of assets, will be, less. And that helps a lot too, because, not only is asset allocation important, but like we've said, the time scale of fires, they can spread so quickly in the grasslands that, if you can attack it early, it is going to be infinitely more better to deal with than letting it, than if it's able to spread 20 or 30 or 50 miles before you can get, enough assets on it to make a difference.
Yeah, that's great information. Doug, thank you so much for speaking to our group, and I'll get an email to you shortly so we can get you an Amazon gift card, is our way of saying thanks.
Okay, well, thank you.
Doing that.
And if you have any follow-up questions, pass them through Steve, and I'll get back to you that way too. So.
Yeah, of course. So we'll go ahead and we'll wrap up here and get to some chapter business real quick. So first, I want to thank Scott and Shannon there at the North Central Texas Council of Governments for hosting us again this year, though, for half of our meetings. So I appreciate again your time with this, your coordination, and the discussions that we've had. So thank you so much for helping being a part of the chapter with this. The only announcements that I have on my end is that again, we'll be holding elections next month. Both the position of president and treasurer are going to be open, so we'll be taking nominations for that and for all the positions. Greg, Dave, Stanley, I don't know if you have anything on your end announcement-wise.
Yeah, the gift card. The gift card to our speaker.
Yep. Once I get that address, I'll get that to you, Stanley.
Okay.
Dave, Greg, anything on your end?
Nothing here. Just hope everybody remembers next month is the last one and for the summer vacation. So plan on attending next month.
Yes. And to announce that will be May 14th at noon, that Tuesday. It will be held at the Weather Service office in Fort Worth. And our speaker is going to be Lisa Bucci. She is a hurricane specialist at the National Hurricane Center and a former hurricane hunter. So we're going to have some fun there. I don't have anything else. So it's top of the hour. So meeting's adjourned. Thank you very much. And we'll see you all next month.
All right.
Thanks a lot.
Thanks a lot.
Thank you, Steve.
Thanks for having me.
Yeah, thank you, Doug. This was great. I appreciate it.